great question. A Mars Interact mission is almost like a practice run to Mars. When we come out into the desert, here we're in Utah at the Mars Desert Research Station, in an environment that's a lot like Mars, and we practice using the equipment, like these suits, like those rovers, and the operational practices, like the scheduling of the astronauts, and the way we maintain the habitat throughout the day. This way we can get a sense of how these things work in context, and perform various kinds of research similar to what astronauts will do on Mars. There's astrobiology, geology projects, and human factors, which studies how astronauts behave when they're cooped up inside of a small habitat for long periods of time.
The Martian atmosphere is over 100 times thinner than Earth's atmosphere. It's also made up of mostly carbon dioxide and only 0.2% oxygen. This means that we as humans won't be able to breathe in that environment, and therefore we need a protective suit around us at all times to allow us to breathe. The suit itself is made up of the protective helmet as well as our spacesuit and gloves. This is all to protect us from the Martian radiation and also the Martian temperatures, which can get down to as low as minus 75 degrees Celsius. We also want the spacesuit to be as maneuverable as possible because we're going to have to be going on missions on foot, and we need to be able to move around as much as possible. The helmet itself has a fan in it to allow us to breathe and also to prevent the helmet from fogging up when we're breathing too heavily.
So the actual astronaut suits have a lot of stuff which is life support system, but here at MDRS we have two different types of suits. Back behind me is a one-piece suit, which, as the name suggests, it's just a one piece. It's like the bag that you take to school, something of that format, you know, the basta or the bag. But this has all the life support system. It has a air cooling system which sends air, and therefore there is no fogging inside here. And you can easily hop inside into this one. So you just have to go like this and then put the other hand, and then you can go inside that. And then there are these more fancy ones which are good for photographs, as well as some of my crewmates liked it. These are the two-piece suits, and they have to be assembled together, and the visor or the helmet is separate from rest of the things. So actually most of the suits will be of this format, and you have to just basically switch on and off the airflow, and you can see the airflow can be increased or decreased in this one. You have to keep them charging, and there are these helmets. So these helmets, whenever we come back, we have to clean them using this thing. So that's a great question. So regarding the food, we have to use something like dehydrated food, because we cannot carry a lot of food on Mars. So the weight is a big factor. That's why we dehydrate it and take it as lower weight, because every weight that you have to carry amounts to a lot of launch mass, and it turns out to be more costly. So you can see all the food that we have here is kind of dehydrated, but at the same time in the fridge there are some resources that we get from Earth.
Thanks for your question. So as you can see here, the soil at MDRS in Utah is very red, and that's similar to the soil on Mars due to the high iron content. It also has other similar chemical compositions, which makes this place a great analog for the kind of soil we would see on the real Mars. Thanks for your question. So that's actually a really interesting topic, because scientists don't exactly know what generates methane on Mars. There's a few ideas. One main one is that it's interactions between water and rock that releases certain chemicals that can turn into methane. Other things think that it might be due to maybe a biotic process, like a living organism, but we haven't seen evidence of that yet. So it's still kind of a mystery, but we're running a lot of cool experiments to find out more. That's a good question. So we know that there once was liquid water on Mars from evidence of big features and canyons that have been carved out, similar to how water carves out features on Earth. So with that comparison, we can form a pretty good hypothesis that Mars, and ancient Mars, had flowing water. We can also see deposits that look very similar to lake beds, so we think that there are also lakes in addition to river systems. Today, there's no liquid water that we can detect, but we do have a lot of ice. Some of it is water ice, but a lot of it is carbon dioxide ice, and most of this ice is locked up in the two polar regions in large ice sheets, and then there's also a lot of permafrost in the soil. So because we know that there was once liquid water, that makes Mars a pretty good location to look for life or evidence of past life. We don't know if there would be real aliens living there right now, but we could definitely try to search for microbial activity, which is what a lot of rovers are up there doing right now, searching for biosignatures. That's a really good question. So on Mars, the gravity is 38% of what we experience on Earth. As we swallow food on Earth, our esophagus is working with gravity to get that food down in a function of your smooth muscles called peristalsis. So your smooth muscles contract and push the food down your esophagus. So on Mars, that process would have to work harder, and thus it would take more energy to swallow your food. Just think of it as your food doesn't want to go down as much when it's on Mars, so your muscles have to work much harder.
Great question. So just like we can see Mars from Earth, we can also see the Earth from Mars. If we want to see some farther away objects, just like we do on Earth, we would need some big telescopes, kind of like what we have here in the MDRS observatory.